All right, you're with the Vintage Tech. What we have here today is the enviable Seiko TV and FM stereo receiver watch. This is the model TR02-01. It is the television watch that was featured on some TV shows, 007 and some others. And this is the watch and a TV screen and watch and stopwatch. And the watch and stopwatch works fine here. Don't have it set to the correct time, but whatever. And it came with the power supply, 300 milliamp, 3-volt power supply, external power supply, the interface cable that snaps onto the top of the television and runs up your sleeve to the receiver, plugs into the receiver, and then it came with some Seiko headphones that would plug into the headphone jack. And then this is the leather, genuine leather case that would either hook in your belt or fit in your pocket. So I've been looking for one of these for quite some time, one that I could afford, and the seller was not able to get any video on the screen, but the FM works, and he didn't know anything other than that. So I have a TV channel playing here in the shack, actually three, one UHF and two VHF channels playing currently, and so we're going to hook this up, and I've had a chance to kind of hook things up and just do a preliminary test, and so I'll walk back through that sequence. I have some external power here, and so let me explain what I did to start out. First of all, I start out by placing two batteries in here. There's very little, almost no corrosion on the terminals, so I put two batteries in there, turned it on, and it played in FM mode. The radio played through the headphones. No problem. When I would turn on TV, the audio level would drop to less than half. So I knew there was something going on with the signal, or with the loading of the set for some reason. There's an on-off. When you're not in FM mode, radio mode, and you're in TV mode, you can turn the TV on and off on the screen and still have TV audio. So that was the principle behind that. So it's really very simple. Volume control here, tuning control here, and VHF low and high, and UHF. So then there's a brightness control on the back side. One of the interesting things about the Seiko is it is not a backlit screen. So you can't watch TV in a dark room because there's no backlight. And so that was an early I've forgotten what year. I'll put it up on the screen when I get ready to edit this video. But in any case, at that time, they didn't have any backlight, and there was not even any light for the... So the clock works. These are the connections that connect to the interface, the TV interface cable. So where was I? So anyway, I put batteries in it, and I got FM stereo, and TV. I was able to tune in a TV's channel and had TV audio. But then the batteries expired pretty quickly. So I hooked up the Seiko power supply, and it didn't work at all. I don't even think I got an FM stereo. So I checked the voltage, and the voltage is fine. So I thought, So I tried new batteries in the Seiko, and I got real loud audio, both TV and FM, but that only lasted just a couple of minutes, and then it started to disappear. So I thought, okay, there's definitely something going on here. Still no video, and so I decided to hook up an external power supply here with regulated current. And so I plugged the external power in here, even though I had just tried the Seiko power supply, and fired it up, brought the current up very slowly, until the unit fired up. And believe it or not, the unit was playing but drawing a full 1 amp, 1000 milliamps. Now my guess is, if this is a 300 milliamp, you're probably only pulling about 100, 150 milliamp when the TV is running and everything off of the power supply. So it's pulling 10 times too much power. So there's something in here, and I still didn't have video, even though I had strong audio, both TV and FM, with external power. But the amp meter on the power supply was reading just over 1 amp, a little over 1 amp. So clearly something in here is shorted, leaky, capacitor, whatever, that's creating a problem. And so that's where we are at the moment. So what I'm going to do now is I'm going to open this back up, I haven't opened it up yet, but I'll open this up and we'll do a little bit of checking, doing some voltage checks. Actually, what we could do is do a voltage check here. There's a fellow in Germany, I think, Delaware maybe, Denmark, yeah, Denmark, that has done some work on this years ago, and he identified the voltages and the signals on this interface cable, both on both ends. And so what we can do is check those voltages, and we may even, for giggles, just check and see if we have a signal on video signal. I think there's a composite video signal and a video sync signal. So there's 3 voltages, a couple of grounds, a video sync signal, and a video composite video signal that come in off of this into the television screen, into the LCD screen. So let's do that. Let's check the power here. Plug this in. These 2 blue marks line up. And we'll hook up our external power. Leave it turned off. Power's on, 3 volts. And just so you're not left out, we will hook up the external amplifier, because you won't be able to hear anything in the headphones, of course. So we'll hook up the external amp for audio, put it on FM, turn the volume down, turn it on. All right, so we have audio on the FM. My goodness. All right, so let's switch this. Oh, and let me bring you up to the power supply. I'm going to move the camera abruptly here. 880 milliamps. Let me switch it to TV. $890. Doesn't make, it doesn't make any difference. Turn that off. Well, there we go. There's TV, and actually the voltage bumped up to 90. Now there's TV turned on to the cable, and you can see that the voltage is up to 940 milliamps. So it's almost an amp, and that's without the watch plugged in. So we don't have the watch plugged in, but we're running on TV mode. I'm on VHF low. Let's see if I can get a channel in here. Okay. Okay, at this point, we confirmed that the unit definitely has some kind of internal shorts or a problem. So I'm going to go ahead and just jump right in and start opening up the set and get into it and start checking some components to see if we've got some shorts. And so we'll see where all of this leads. Got all the screws out, and this end pops off. There's a clip in the front there that are very fragile, and those cracked. So this ribbon cable pulls out. We can do this without damaging it. Okay. There we go. So that just pulls out. Very fragile. All right, let's see here. Okay. There we go. It just slides down. Okay. Just slides straight down. Okay. And now we've got more screws to hold all this together. All right, let's pull these screws out. The chrome screws inside. Okay. This is magnetic. Okay. The advantage of a magnetic pad. Okay, that's a long screw. So we've got two at the top, a long one in the middle. I wonder if this is another long one. Yep, two long ones in the middle. Okay, and I wonder what these are on the sides. Short. Okay. Nope, long ones. Longer. Okay. There we go. Come on. Okay, so we've got the two longest ones on the end, two short ones up here, and two middle length, medium length screws there. All right. So now this lifts up. And probably just pulls off. Yep, sure enough. Just pulls up. There we go, and it's just a bezel. We got to make sure we get those switches lined up. There's the tuning bar. It's just a rheostat, just a pot, linear pot. All right, any other screws? Oh, I missed a screw right here. And it's the same length as the middle screw, so we'll set it there. Put these here. There we go. That's why we document everything on video, because you just don't know. Definitely something there. Oh, look right there. Phillips screw. Okay. There it goes, and that's another long one. I'm off screen here, sorry about that. Yeah, another long screw. So now that ought to lift right up, and it does. All right, so let's check again, make sure we're not missing any other screws. There we go. Okay. Now we're getting somewhere. So this is the section that heated up, and there are caps in there, which would be very likely bad. I mean, you know, that's just the whole story about capacitors and how they age and fail. So I'm not sure how we're going to get to those. Got to pull this board loose somehow. Oh, okay, there's a pin. So this is probably a piece of tape right here, or some kind of a retainer. Just a retainer, that's all it is, a retainer pin. Okay, and that releases the tuning knob. Sorry, I'm off camera here. I'm trying to concentrate on what I'm doing and trying to keep the TV receiver on camera. Okay, it's got a catch in there. On this side I can see it's geared. It's actually a gear. So let's see if we can do this without losing any parts. Yeah. So that this is an outer gear, and then there's an inside gear that spins that tuning shaft to give you a nice, smooth, precise tuning. There we go. There we go. All right. See that? That gear fits inside that hole and tunes it. Right, it's just kind of coming apart like a little puzzle here, but we probably have another ribbon cable or something that we've got to be careful about. Okay, the whole thing's coming out. All right, no more ribbon cables, thank goodness. I hate those things. All right, here's some caps that are hot. I don't know what that is. A choke, maybe a transistor or two that's overheating. That could be a transformer. All right, so we're able to get to all of these capacitors, these two here, this one back in here. I'm sure there's probably soldered ribbon. Yeah, I can see there are soldered ribbon connections between these two boards. All right, once again, we'll pause and I'll update you. After a little bit of study and just looking at the board, I discovered how the basic concept of how the unit works with the power supplies, providing 3 discrete voltages all the way through the set and all the way to the LCD watch. So I'll explain just a little bit about how that is laid out and how it's working, how the switching power supply works off of 3 volts and produces 11, 30, and 5 volts. Through this transformer, these 2 transistors go into oscillation through this transformer and create AC voltages, and then these diodes rectify those AC voltages and filter them. And you can adjust this pot. I'm sure, yeah, this pot adjusts all of those voltages. Probably that adjusts up and down the 3 or the 2 higher voltages. And when I say higher, I mean low voltages. So we'll take a look at that schematic and explain it online. But for now, let's just check just to see if these caps are any good, and these 2 caps here are any good. Let me zoom in here. Set this thing right here. Check those 2 caps. We're testing some caps here. I want to give you kind of a summary of what we ended up with. We had to split the 2 boards apart and remove the 2 ribbon cables that were holding it together, and then we fired everything back up and used the thermal camera to do some troubleshooting. So that's what we're going to do right here. We've got it plugged in. We're going to turn the power on now, and you'll immediately see components beginning to heat up.
There's something. Watch the center.
Okay.
Right here.
Yep.
So that's...
Oh, you got 0, cool, so we're good. So something in there.
It's probably that cap. Right, you want to flip it? I guess it could be that diode.
That, yep. Okay, you ready?
Alright, where's the switch? Here. Okay.
Go.
Switch, I guess. Maybe this switch.
880 milliamps.
Okay, I'm gonna get closer and look.
$890, $730, $870.
Still on?
Yep. $890.
Wait, why is it still on?
$890.
I cut it there because I thought I turned it off. Oh, I didn't. Okay.
Oh my goodness. Which one?
So it's actually not that hot because you can see my hand. But it's this transistor, and then yeah, it's that cap.
This one?
The little cap. Here we got a pair of tweezers. Hold on, just give me him of these real quick so I can point. I think it's that one. Yeah. It's that little cap.
So what is that telling us? That it's
probably shorted?
We decided to remove that one cap, and now we'll fire it back up without that cap in there, and we'll see what kind of problems we still have. 5049,
490,
500 milliamps.
All right, we're still heating up in that area.
Okay.
Cutting it. It's better than it was though.
Yep. It's almost half. Yep.
But what is that? Is that the diode?
I believe it is.
All right, we'll check that.
So that cap.
Right, ready for power?
Yep.
All right, power's on.
Okay. Main power's on.
140 milliamps.
And TV power's on.
900 milliamps.
TV power's off.
140.
Okay, so that's a regular power right there.
All right, that's good though.
Okay.
So is the regulator heating up, or is it good?
Regulator still.
Not too bad. I mean,
80.
Yeah, 80 something. It's good. Nothing on the board getting hot. So
let me flip the TV back on.
All right. 940.
Okay. Let's see. Where is the TV is downward. Wasn't even on TV. Oh, that was VHF. All right, I'm gonna turn it back on to FM. There's FM. All right, and what kind of current we got?
140.
All right, I'm gonna turn on TV. There's TV.
140.
All right, now I'm gonna go back to TV up here.
130, 140. 940.
Okay, so we got a spot warming up right here.
All right, so probably on the back, there's probably just another cap there. I had to guess.
Let's flip it.
I see this. Where is it? This region over here is starting to heat up.
Yeah, that's what I'm saying. Right in there.
Yeah. We're only at 140 though, which is good. That's probably
82. That might be normal. If I flip it to TV, should I do that and see what heats up, or let us cool off?
Look at it. Can you get it to it from the side? Can you look in? Or actually, let's flip it up.
Okay.
Ready?
Yep. You can hear Jesse calling out the amperage of the board that it's drawing. We had hooked up, but we're still not right. There's still something that is that's starting to short. Oh no, that's TV mode.
Okay.
Wait a minute. Is it?
140.
Leave it on there.
140.
Okay, there's FM stereo.
Still 140.
And there's TV mode.
Still 140.
All right, when we turn the TV video on.
Still 140.
Right there.
Still 140. 150.
We continue to troubleshoot with the thermal camera, and then we discover an intermittent problem with the power jumping suddenly. All right, so we got something loose here or something.
490.
Power consumption should be about 120 to 140 milliamps, and it's jumping up into the 500s again.
490, 470, 440.
All right, it's getting nice and warm in here.
400, 470.
What have we changed?
140.
What?
Just dropped. It was at 470 and it just dropped out.
What is it now?
140.
All right, I just moved this board right here. This illustrates the value of using multiple test points. We're testing the current and we're doing a thermal camera to determine where we've got some intermittent connections. Still 140?
Yeah, still 140.
All right, I want to bring you up to speed where we are on the Epson/Seiko TV watch, 1982, 1983. We've got the boards. We took the boards apart, separated them by desoldering the pins that are the ribbon cables. There are two sets of two ribbon cables, a long one and a short one. And we separated the boards and found, using the imaging, the heat camera, infrared camera, we detected a couple of bad capacitors that was causing a short in the whole power. That we were pulling about 800, 900 milliamps. In fact, the previous clip that I just shared with you was over I was like 1.2 amps. So we knew we had a problem in the power supply here, something drawing so much power. What are we looking at now, Jess?
Same.
Okay, we're at about 140 milliamps now, which is perfect. That's about what we would expect. 520, 530, 520 milliwatts with the TV on. The TV is switched here, so I'm going to let you see that the TV is turned on, the power is turned on, and over here on the scope we have the video signal of this TV station.
Weeknights at 7, 6 Central on BTV.
And I don't have it tuned in real well. Let me tune it in. So you can see that's the actual composite video signal. When we get it tuned in, we'll actually have video.
The same. As usual, I am writing real slow because I know you can't read fast.
Okay, so that's the video signal down here on the cable that connects to the phone. So that's the interface cable that connects to the phone, that connects to the watch. So we were able to restore what we thought was most of the power and eliminate the short on the receiver. Now what we've got is we're missing a couple of voltages over here on the interface cable. We have video and we have video sync, and we have 1 or 2 voltages, but we're still missing the 8.9. I think we had the 13. I don't remember. We have the 4.1. We know that. And I don't remember what we had on pins 1 and 2. Let's just double check that. There's pin 1 and it's 0. And pin 2 is 0. And we're AC coupled here. Jesse, is that okay? Okay, so there's pin 3, and we've got 4.5 volts. Okay, there's pin 2. We have 1.36 volts, and we're supposed to have 13. And then pin 1 is basically 0 volts. It's just got a couple millivolts there, and we're supposed to have 8.9 volts. So we're missing some power, and we do not have video on the watch. We hooked the watch up. We can't get any video on the watch, but we know we've got video to this point, which is good. And I suspect that either we're missing some power to the watch to power up the LCD screen, because these other two are wrong voltages. So I'll continue to replace. I'm going to take the boards back apart, and I'm going to replace all of the electrolytic caps. The strange thing is the electrolytic caps check fairly okay. Some of them are definitely checking bad, no question about it, and some of them are testing kind of sort of okay. But clearly we've replaced replaced this one. I've got to get a shorter one for this, and there are several up underneath here that we have replaced, 2 or 3 that we've replaced under here. So that's what the next step will be. But I wanted you to see, and I will I've got pictures of the boards taken apart so that you can see those boards separated if you ever attempt this. This has been a two-man job this evening, and we're working with very fragile parts. As you can see, this ribbon cable is not going to take any abuse whatsoever. That's going to have to be unplugged again, and these ribbon cables will have to be desoldered and pull the boards apart later, but I'll get to that in the next step. So anyway, we're listening to MASH on UHF channel, I don't know what it is, 30 I think, and that's what we're currently tuned into. The FM radio works. Let me flip it to FM. We got a stereo light.
Still doubt that God can speak. Grinder. But then this friend said that he...
So anyway, that's the FM, and it's working great. So we're testing this audio through the little portable speaker that I built from a little chip amplifier. So that's working. Everything is so far so good. All right, we're going to pull this apart. We're going to desolder the ribbon cable and pull this apart and replace some bad capacitors. We replaced the power supply cap here, which I need to get a smaller one to fit that, and there's a couple underneath here that are in need of replacement. We'll take care of those. And then there's some underneath this tuning slide, there's a couple of caps that I'm pretty sure are bad, so we're going to just replace them all and have it all done. Okay, I've got the boards apart. You see the tuning board here, or the RF board, and this is the other board. I've replaced a couple of these caps. I don't know about these two here, but now I got to get up inside here somehow and get those out of there. So I've got some work to do. Once I got these boards separated and the caps pulled off of the board, I discovered some terrible bleeding of the electrolyte on these caps that destroyed the circuit board. So you can see from these photographs on the microscope how damaged the circuit board was underneath the electrolytic capacitors that had bled their electrolyte and completely eaten away the copper traces and copper vias. So it was no small task trying to repair this damage. Okay, we're going to go back over this just for those of you that may want to figure one of these out and get them running again. These are the two boards that are mounted together with these ribbon cables right here. So there's two ribbons that are that hold these two boards together, just like this. And there's your switches, and your switches on top, your headphone jack, and there's the external connector that goes to the television. So you desolder these ribbon cables and pull the boards apart like that. And then there are a number of capacitors in here that were bleeding and destroying the circuit board. These tested okay, but these were bleeding, as you could see in the pictures. And these 4 were really, really troublesome. So we pulled those up and had to rebuild the board underneath the caps, running small wires underneath, soldering the bottom side, soldering the top side, and then reinserting the cap and soldering them in. And then there are some caps up underneath the tuner. This variable resistor right here runs up and down the rail when you turn the knob. And there's 3 caps. There are 3 caps up underneath there. And then there's 3 caps here. One is a tantalum cap, and then there are 2 electrolytics. I replaced all of these caps. I didn't replace any of the tantalum, but I did replace this tantalum cap, but I replaced all of these, repaired the circuit board, these here. Replaced, these are inductors. There's a diode right there that was fine. All the diodes are okay. The transistors were fine. These transistors create a switching circuit power supply, and there's the input for the power, 3 volts. So there's the volume control. So I wanted you to see the board up nice, close and personal. And so that's it right there. This is the brightness control. So after rebuilding this board and getting these voltages, finally getting the voltages that we needed on the the external terminal, the terminal that goes to the television, we had proper signals. This board takes power in and produces the TV signal and the FM stereo signal, and then sends the signal back out and comes out to the external connector. There's the stereo light right there. So there we have it, Seiko's television watch circuit board. So after replacing these caps and troubleshooting, that took some time. Believe me, we spent considerable amount of time on getting that going, and but we did finally get it going. This is the TV signal, comes into the main board. So there we have it. So let's see the finished product now.
Wait for it. The WCCP WeatherWise app.
Just what you need when you need it.
Powered by Hoyt Cleaning and Restoration.
If you're suffering from lack of money, talk to your doctor about Bargain Max. Bargain Max is proven to save money.
And that's a normal picture for this watch. They said it was a very poor, low definition, gray, blue-gray.
Flexibility and water protection. Nobody wants to replace their roof. Restore it instead with Roof Max for 80% less. Call now for a free roof inspection.
A Bojangles family meal has more to choose from.
Coleslaw.
Dirty rice.
Well, there you have it. I sure hope that you've enjoyed watching this Seiko 007 watch repair. And thanks for watching Vintage Tech.